Okay, so in this video, we want to go through a procedural approach and an object-oriented approach to solve the same problem. So the idea is we're going through, I think this is challenge 6 of Project Euler, and we're going to do it with a C# console.NET framework project. I've called it Sum Square. You'll need to make sure it's saved on the W drive if you're working on this at school. And I'd suggest that the first thing that you do is always just to get all the information that you've got and put it in the comments. So we want to find the difference of the sum of the squares of the first 100 natural numbers and then square the sum. There's quite a lot of maths involved there, but let's see if we can work out what we need to do. Shift, Alt, Enter, make it full screen. So we'll start procedurally. We'll do it all in a procedure, just from top to bottom, and then we'll do it object-oriented. So we want to be able to find the sum of the squares of the first 100 natural numbers. So if we're going through the first 100 natural numbers, that sounds like iteration to me. I'm going to need a for loop. For, let's say I will start at, well, a natural number, does that include 0? Doesn't look like it does. We'll start from 1. Can we pop that? No, we can't do part screen, can we? When it's full screen. It needs to be less than or equal to 100, and we'll increase by 1 each time. Okay, and then we want to add them all up. So we want to square I, and then keep a running total. So we're going to do it procedurally. Let's maybe keep track of the total. Int total equals 0. Let's square the number and increase the total. So to square it, we can do I raised to the power 2, or just I times I. And then increase the total, we can just do total plus equals to increase the total by the amount squared. Okay. That should find the sum of the squares and then the square of the sum. So what does that mean? Do we just need to get that amount and then square the total? So we don't want to do that inside the for loop. We'll want to do it down here. So let's do the total, multiply by the total. Let's say int sum squared is equal to that, and then we can display it. I nearly did print. I'm thinking in Python. Console.write line. The sum of the squares of the first 100 natural numbers is, and I really want to say the square of the sum. And then I want to be able to display it, which means we'll need to pre-process it with a $sign and plop in the name of it. We call that sum squared. So will it work? We shall see. So this doesn't even use procedures or functions. It's pretty nasty. It's just not particularly code that you can repeat. This doesn't look very good. We've got a negative number in here because it's going to have to be probably something that's too big to fit into an integer. So an int is 32-bit. Maybe if we change that to a long, because a large number squared is going to be too big to fit into 32 bits. Let's try it again. Yeah, that looks more promising. I'm not logged into Project Euler, but if you test this, then hopefully that should work. So this is a pretty terrible way of solving a problem. It's not replicatable. You can't change it to get the first 1,000 or the first 50. I want to be able to check it for the first 10 and see if I get 385. So I'm going to make it procedural. I'm going to put it into a procedural function. I want to be able to say, what should we call it? Sum of squares. I want to be able to do sum squares up to the first 10 or up to the first 100. I want to be able to do that. And then this time, instead of saying always 100, all of the calculations should go inside this function. I know it's a function because it returns a value. So can we Alt-Enter and implement it? Yeah, there we go. Generate the method. It's not implemented yet. It will throw an exception. But we put the implementation inside that procedure. It's procedural. We're splitting it up into procedures and functions. We now have a parameter that says how many. So I'm going to call that n. That's how many numbers we're dealing with, how many natural numbers. And that n is now the upper bounds of our iteration. And then all we need to do after our iteration, after that control scope here, we're going to return that value. Don't need that, I don't think. Oh, no, I didn't actually do the squaring bit. I want to work out the sum squared and return the sum squared. And that value is going to go in here. So the beauty of this is we should be able to customize it. So we can say, how many do we want here? So int n equals console.readline. How many natural numbers? This is going beyond Project Euler now, but it's procedural. We can repeat it as many times as we like. Readline returns a string. I want to store it as an integer, and we can't do that until we parse it. So parse means try and convert this string into an integer. Right, what's the problem now? Oh, because there is no readline with a parameter, you have to display it first. Sorry, I always make that mistake. Console.writeLine. We'll put our prompt in there. Then we read a line. The read line returns a string. We convert the string to an integer and we can store that there. We can then use that in here. Even better, we can display it in here. All right, will it work? No. What's wrong? Where's my errors? Error list. Let's see. Oh, I'm just missing a semicolon. Oops. How many natural numbers? Let's go for 10. And it says the sum of the square of the first 10 natural numbers isn't the same as what Project Euler says. So here, I've made a big logic error. We try to work out the sum of all the squares, and then the square of the sum, and then work out the difference. That's not what I've done here. So let's have the total. And what can we do? We can have long total squared. So the total squared gets incremented by the square amount, but just the normal total gets incremented by I. And then instead of returning the sum squared, we want to return the difference between those two values. So total squared minus total. Will that work? Put in 10. Should be 330. No. So I've got another logic error here. But at least it's procedural. I'll pause the video in a moment and we'll try and track down that, that logic error. I'm going to put some breakpoints in so we can step through and see what's happening. For now, let's just work with 2. A breakpoint means the code will pause at this point. I can press F10 to step through. So I've got total and total squared. I'm starting with I as 1. And I want to keep going until I is equal to or less than n, and n is 2. So our total, which is currently 0, is going to be increased by 1. And 1 squared is going to be 1. So our total squared is also going to be 1. Next time through our iteration, this time I is 2. So our total was 1, is going to be incremented up to 3. Yeah. The square, well, 2 squared is 4. So we want to increase our total squared by 4 to make it 5. And then we can return the difference between the two of them, which should be right. So what have I done wrong here? Yeah, so it's a logic error, a good example of a logic error. It should be the difference between the sum of all of the numbers squared, take away the sum of all of the numbers then squared, and I've done it the wrong way around. So it should be total times total minus the total squared. So there's at least 3 different skills involved here. One, and I think the most important, is the problem solving. Do you know mathematically what you need to do? The second is the syntax of the programming language. Can you convert what you want to do with your problem into the syntax for the code? And then finally, can you think of an elegant way of using data structures and programming techniques to solve the problem? Will this actually work this time? Let's see. If I put in 10, 2,640, even that doesn't look right to me. Oh dear. Oh, it is right. Hooray, at last. So in theory, if we put in 100, that number should work. Okay. So whether or not we've solved this problem, that's irrelevant really for this, this lesson. Today we're talking about different paradigms, different ways of solving a problem. What we want to try and do now is, instead of just having a procedure or a function, so we're moving from our procedural paradigm into an object-oriented paradigm. So things like classes and objects. So I would like a class in here called a natural number solver, and I'd like to be able to throw some stuff at it, like calculate the sum of numbers squared. So it returns a long of sum of squareds of the first n natural numbers. Just return 0 for now. How does it phrase it in the problem? The sum of the squares and the square of the sum. I can't type, sorry. So I'm going to push the / thing 3 times to describe what's happening. So this is going to calculate the sum of the first n natural numbers squared, e.g. 1 plus 4 plus 9, or n equals 3. So n is the number of natural numbers. This time, the square of the sums, we're just going to add up all of the numbers and then square it. I'm going to put that in brackets. It's as clear as I can make it. And then we want to be able to work out the difference. So this time, if we want to calculate the difference, what do we mean? Well, it should be the difference between the sum of the squares. So square of sums, is that right? No, sum of squares. Which I'm so confused. I want to be able to do 3025. That's the sum squared. Square of sum. that one minus the other one, this one. So that's all of the numbers squared, then added together. See how important it is to choose sensible method names? So what's the point of doing it this way? Well, it's trying to make your code a bit easier to understand. It's putting all of the functionality inside a class. Now we just need to implement it. So which one round is this? We need to iterate from 1 to n. And we want to square the number and add that on to a total. Increment each time and then return the value. This time we want to add them all together and then square it. So I'm going to do the same kind of thing. Modular code, we can kind of just repeat if we need to. But this time we're only getting the sum of all of the values, not the sum of all the values squared. And then we square it afterwards. Okay, so this time, if we want to be able to use it, I need an instance of my class, natural number solver. So let's try natural number solver. Let's call it Bob. Terrible name. You should never. You should always make sure your identifiers describe what it's actually storing. We make an instance of that class so that we can access the methods inside. I can't access the methods inside because they're not public. Let's make them public. And try again. Oh, that's the only one I want actually. So Bob dot. Well, at this point, I'm not really sure what I want to do. I only really want to calculate the difference, so I don't know what these need to do. So I'll keep those private, thanks very much. The class itself needs to be able to access them, but no one else does. Just leave those private, keep that public. That's the only one we need for Project Euler. So that when we go back to Bob, our natural number solver, who's a genius at maths, Bob can now calculate the difference for n natural numbers. Let's not do it the procedural way. Hopefully it will still work. Of course it won't. Long sum squared equals. Yeah, brilliant. So, two things to take away from this. One is the whole point of classes is to be able to organize your algorithms and your data structures in a sensible place, to give things sensible names. Today, at last, we get to explain what static means, because it seems pretty pointless making Bob. Why can't I just go natural number solver dot calculate difference? Because calculate difference is defined within the natural number solver class. But in order to access it, I need an instance of that class. I need an object of type natural number solver. Unless I say this is static. So public static long. And in order to do that, then square of sum needs to be static. What does static mean? It means you can access it without needing an instance of that class. You can just use the class itself. Have I got it the wrong way around? Yeah, the static goes before the return type. There we go. So now we don't need to make an object called Bob anymore, because we can just use the name of the class instead of the name of an object. So sometimes that's helpful, sometimes it's not. It's useful if you don't need to be able to store data for individual objects. You just want to be able to access useful methods. Let's try it again, see if it still works. It does. Awesome. Okay, I'm going to end the video here and then we'll go through the slides and the key concepts here. But hopefully it's been helpful. I've gone through quite quickly, but you can work through the video at your own pace, record, rewind. We've got two different paradigms. Procedural means it's just using procedures and functions. Object-oriented means splitting up into classes, objects, methods, attributes. And there's no right or wrong way to solve a problem. There's just different tools for the job.